Let's now look at an example of dynamic NAT. In this case, we are establishing a pool of public IP addresses and a pool of private IP addresses. That way there, we don't have to create individual static translations for every single private and public IP address that we want to have connected to the internet. So instead now, we allow the router to dynamically pull a private IP address and pull a public IP address and put them together as required at that point in time for the translation. So we'll look at the interfaces first here, and the interfaces, for example, the Ethernet 0/1 interface is our outside interface. So IP NAT outside, we still apply to the interface. Interface Ethernet 0/0 is our inside interface, and it is IP NAT inside. So we're still using a lot of the similar commands that we saw when we were creating our static NAT example. But now we need to define the pools that are going to be utilized. So the private pool and the public pool. The private pool is simply identified by an access control list. In this example, it's a standard access control list that is saying 172.16.1.0 through 172.16.1.255. And it's a permit. So as a result, when we are performing NAT, the router takes a look at the source IP address and says, does it fall within this range of 172.16.1.0 through 172.16.1.255? And if it does, since it's a permit, it means I can translate you to a public IP address. So this access list is important. If you get the access list wrong, NAT is not going to be working as you expect it to. You might be translating the wrong IP addresses or not translating the IP addresses you expect to be translated. We define the public pool by using the IP NAT pool command in global configuration mode. And then we give it a name. So we identify it by name, allowing us to have multiple NAT pools on our router if we need to. In this case, they called it NAT pool. And in the pool of addresses is from 209.165.201.5 through 209.165.201.10. So this is a range of values that is being specified. So .5 through .10. So we have .5, .6, .7, .8, .9, .10. We have 6 addresses here that are being utilized in the pool for dynamic NAT. We specify the net mask parameter and give it a network mask. Now, it's important to realize here that this is not the subnet mask that is attached to the IP address while it's being translated. That's not what it's for. First of all, are there subnet masks in packets? No, not at all. Just IP addresses. So why specify this net mask? What is the purpose of it? The purpose of the net mask is to check your work. That's what it is. And what do I mean by check your work? Well, when you specify a net mask of 255.255.255.240, the router does a check to see what the block size is to ultimately determine the total number of addresses that are available within this mask, and more importantly, what are the range of values going to be. So in this case, we see that it's 240. Well, if you take your 256 minus 240, you end up with 16. So we have a total of 16 addresses. Now, if you look here at the addresses defined in the pool, what do we have? We have 209.165.201.5 through 209.165.201.10. Based on this value right here, 16, the router is going to determine whether this address range is legitimate. So what it's deciding now is, what are the subnet IDs What are the subnet IDs? Well, the first subnet ID would be 209.165.201.0. The next subnet ID would be 209.165.201.16. The next subnet ID would be 209.165.201.32. This is taking us back all the way to ICND1 training, folks. So it now knows the subnet IDs. And then it decides, does this range fall within a single subnet? If it doesn't, your router will bark at you. It will tell you that this is an invalid range based on this net mask parameter you're defining. So it's a safety check. It's a mechanism. Now, where do you come up with this net mask? Do you just pull it out of thin air? Well, no. It depends on the range of addresses that have been allotted to you. So typically what you will find is that the net mask value equals the subnet mask that is applied to the interface, that outside interface. Why? Because, as we discussed in our static NAT discussion, this right here is giving us a total of 16 addresses, 0 through .15. Can't use the first 0, can't use the last 15. We're using .1 on our local interface. .2 is being used by the ISP. That leaves us with 12 addresses left over. In this case, our pool has to fall within that range of addresses, because if it doesn't, then it's not going to be advertised properly out to the internet. So if the pool is not part of this range at all, well, then we're going to have to find some way to advertise whatever pool we have or have been given by an ISP that's not being advertised. How are we going to get it advertised? But in this basic configuration here, this net mask is making sure that we don't make a mistake and define a pool that is not an appropriate range of values, meaning a pool that spans multiple subnets. Because that pool, as we said, has to be part of the same network that this interface is part of, because when traffic comes back, traffic has to reach this router and then it has to be translated back. So this net mask is a very important parameter for verification purposes.